Hello my dear students, welcome to my YouTube channel that's Concepts of Chemistry. Before starting today's lecture, please do subscribe my channel. My dear student, today's topic of the lecture is why there's a need to study hybridization. Actually, we made some sets of theoretical observation of some covalent compounds according to their Lewis structures and the strength order of the sigma and the pi bonds. But we got different sets of experimental values or the observations. So there came a new concept of hybridization in covalent compounds to explain that experimental observations. So let's start today's lecture. Why there's a need to study hybridization. But to study that, let's recapitulate the previous lecture, that strength order of the sigma and the pi bond. There I have told you that as we move down in the group of nonmetals, the size of atomic orbital will increase and hence the extent of overlapping of that atomic orbital will decrease. So the strength of sigma and pi bonds will decrease down the group. But in the previous lecture, I have missed one point, the strength order of different types of sigma bonds. So let's start today with the strength order of different types of sigma bonds. Actually, we are having three types of sigma bonds. The first sigma bond will be formed when there is the overlapping of p orbital of one atom with the p orbital of the another atom. So it will be sigma p and the p. The second type of sigma bond will be that have been formed by overlapping of the s orbital of one atom with the p orbital of the another atom. And third type of sigma bond will be the bond that have been found by overlapping of s orbital of one atom with the s orbital of the another atom. Now, in case of overlapping between the p orbital and the p orbital, the extent of overlapping will be the maximum. So the strength of sigma pp will be the maximum. So I am writing strength of sigma pp will be maximum. Then there's come the turn of strength of sigma s and the p, and then the extent of overlapping between the s orbital of one orbital and the s orbital of the another atom will be the minimum. So the strength of sigma ss will be minimum. So here I am writing strength of sigma ss will be the minimum. Now let's talk about the sigma pp down the group. Now the first member of any group will form the sigma bond between the 2p orbital and the 2p orbital. The second member will form sigma 3p and a 3p, and then further will form sigma 4p and the 4p. Now as you move down the group, the size of atomic orbital will increase and hence the extent of overlapping will decrease. So the strength of sigma bond formed between the 2p orbital of one atom and the 2p orbital of another atom will be maximum, and then it will decrease down the group. So strength will decrease down the group. So now let's apply this topic on certain covalent compound structures. So I'm taking an example of methane. To understand the topic of hybridization, let's understand one wrong concept. I'm saying it again. This concept is wrong, but it will help you a lot to understand the topic of hybridization. I'm taking an example of CH4. Let's make the Lewis structure. Carbon. How many valence electron does carbon have? It's 4. 1, 2, 3, 4. Then what we are having? 4 hydrogens. Hydrogen 1, hydrogen 1, hydrogen 1, and the hydrogen 1. Hydrogen has 1 valence electron. After that, the carbon will share 1 electron with hydrogen and will attain the octet of 8 electrons. So this is a Lewis structure of CH4. Now Let's talk about the further orbital concept of formation of covalent bonds or covalent compounds. Here the central atom is carbon. What's the atomic number of carbon? It's 6. Its valence shell configuration will be 2s2 and the 2p2. Sorry. Now, let's draw the block diagram of orbitals of s and the p orbitals. Now, we know that s has only one orbital. So, I'm drawing the s orbital and it's actually 2s. Now, we know that p subshell has three orbitals. That's px, py and the pz. That's the p subshell, and we are having three orbitals in case of p subshells. So in total we are having 3 p orbitals. So it's a 2p. So now let's fill the electron. The 2s is having 2 electrons. So first electron with a spin of plus 1 by 2. The second electron with a spin of minus 1 by 2. Now 2p is having 2 electrons. So we have to follow the Hund's rule. The first electron in first orbital, second electron in the second orbital. Now according to the orbital concept, only when the one orbital has one electron, only then it will overlap with the orbital of the other atom having one electron but with opposite spin. We have done this thing in the previous lecture, that two orbitals will overlap only when both are having one electron each but with opposite spin. But when we focus on the orbital diagram of carbon, you can see that here we are having only two unpaired electrons in 2p orbitals. So here carbon can form only two bonds, but according to Lewis structure the carbon is forming 4 bonds. So that means what's gonna happen? To make the 4 covalent bonds, the electron from the 2s will jump into the 2p orbital. So we are having the excited state. When electron jumps from lower orbital to higher orbital, then the final state that has been achieved is called the excited state, and here this is called the ground state. This is called ground state, and now I'm going to make the excited state. So what's gonna happen? This is the 2s orbital and these three are 2p orbitals. These three are 2p orbitals and they are 2px, 2py, the 2pz. So what's gonna happen? The electron from 2s has jumped to the 2pz orbital. So we got total of 4 unpaired electrons to make the bond with 1s orbital of the hydrogen, because hydrogen, let's talk about hydrogen. The atomic number of hydrogen is 1, so its valence shell configuration is 1s1. So that means hydrogen is going to overlap his 1s orbital with 2s, 2px, 2py and 2pz orbitals of carbon. So let's talk about it. I'm taking my first hydrogen. His 1s1 configuration will overlap. The s orbital will overlap with the s2s orbital of carbon. So we got the first sigma bond and it is sigma s and the s. Now let's talk about the another hydrogen. 1s1, and the s orbital of hydrogen, second hydrogen, is going to overlap with the 2px orbital of the carbon. So this bond is sigma s and the p. The s orbital of hydrogen is overlapping with the p orbital of carbon. That's why this bond is sigma s and the p. Now let's talk about the third hydrogen. That's 1s1 again, and this hydrogen is also overlapping with the 2py orbital of the carbon. So the sigma bond has been formed by the overlapping of s orbital of hydrogen and the p orbital of the carbon. Now let's talk about the fourth hydrogen, that's hydrogen, and its configuration is again 1s1. Here the s orbital of hydrogen will overlap with the 2pz orbital of the carbon, so the sigma bond has been formed and it's again sigma sp, because here's the overlapping of s orbital of hydrogen with the p orbital of the carbon. So now let's come to the diagram. That means here we are having 4 sigma bond. The 4 sigma bond is the sigma s and the s. The second one is sigma s and the p. The third one is sigma s and the p. And the fourth one is sigma s and the p. Sigma ss means the s orbital of hydrogen is overlapping with 2s orbital of carbon, and sigma sp means the s orbital of hydrogen is overlapping with p orbital of the carbon. So in the structure of CH4 we got two types of bonds. The one is sigma ss and the other three are sigma sp. So that means now let's come to the strength order. The sigma sp is more stronger than sigma s and the s. You can see that the sigma s and the p is more stronger than sigma s and the s. That means in case of CH4, what's gonna happen? In case of CH4, we are going to have one weak bond and other three to be strong bonds, and the other three will be strong bonds. And according to the Lewis structure, all the bond angles will be 90 degree. So this is our theoretical observation. So this is our theoretical observation. But in reality, what happened? In reality, I'm writing the experimental observations. I'm writing in reality experimental observations. The very first observation according to experiment was that all the 4 bonds in CH4 will be of equal strength. But theoretically, what we have proved? But theoretically, one bond is weak and other 3 are strong. You can observe it from the diagram that one bond is weak and other 3 are strong bonds. But this is not in the reality. In reality, what we are having that all the 4 bonds in CH4 are of equal strength. But theoretically, we are saying that one bond is weak and other 3 are strong. So in reality, all the bonds are of equal strength. And what's the second experimental observation? All the bond angles are equal in 3 dimensions. In 3 dimensions with a value of 109 degrees and 28 minutes. So this is the experimental value. But theoretically, what we have said, But theoretically, what we have said, all the bond angles are of 90 degree. So that means our theoretical observations were actually wrong. Theoretical observations are wrong and experimental observations were correct, and they states that all the four bonds in CH4 will be of equal strength and all the bond angles are equal in 3 dimensions with a value of 109 degree and 28 minutes. So that's the experimental values, and to explain these results, there's a origin of new concept called valence bond theory, or more preferably hybridizations, which we are going to start in the next lecture. I hope, my dear students, you all got the basis of introduction of the hybridization. We did some theoretical observations in which we were getting, in case of CH4, that one bond is sigma SS, other three are sigma SP. That means one bond is weak and other three are strong, and all the bond angles for 90 degree. But these theoretical observations were wrong, and experimental observations stated that all the bond angles are 109 degrees and 28 minutes, and all the bonds in CH4 are of equal strength. To explain these experimental observations, the correct observations about the covalent compounds, there's a need for an introduction of new concept called hybridization, which we are going to study in the next lecture. So that's all for today. I hope you all understood today's lecture. If any student wants to book a paid one-to-one online class to clear their doubts, then she can contact me. My phone number is mentioned on thumbnail of this lecture. Please do like, subscribe and share this channel to maximum number of students. Don't forget to press the subscribe button. Stay blessed.